This problem asks, what is the limit as n approaches infinity of 3n cubed minus 5n, all divided by n cubed minus 2n squared plus 1, is what? The first step is going to be to recognize what is the biggest exponent. We can see that cubed is the biggest function here. Thus, we will divide both the denominator and the numerator by n cubed. So we will get 3n cubed minus 5n all over n cubed minus 2n squared plus 1. And then basically we'll just multiply this by 1 over n cubed to both sides, which is, this whole expression is equal to 1 actually. But that's why we're able to do this. And then we can simplify this. We then get 3n cubed minus 5n all over n cubed. We can do the denominator now, and we get n cubed minus 2n squared plus 1, all divided by n cubed. We can simplify this further, and we get 3 minus 5 divided by n squared all over 1, and n cubed divided by n cubed is 1, minus 2 over n, because n squared divided by n over 3 is 1 over n, plus 1 over n cubed. Then we can now evaluate the individual limits. So basically using limit laws, we can break this expression into a bunch of different limits. So we can get the limit of 3, then we subtract this from the limit of 5 over n squared, and these are all as n approaches infinity, And then we divide this whole expression by the denominator, which is divided by the limit as n approaches infinity of 1 minus the limit as n approaches infinity of 2 over n, and then plus the limit as n approaches infinity of 1 over n over 3. Sorry, I'm running out of room here. I'll open up some more space so we can have a bit more room to work. So from this, we can now see, we know the limit of 3 is equal to 3 as n approaches infinity, because 3 isn't even a variable in the expression. So we just get 3 minus, what is the limit as n approaches infinity, of 5 over n squared. Well, if we have a massive denominator, that's going to make the expression very, very close to 0. And when we approach infinity, we're going to have such a massive denominator that this will basically be equal to 0. So we get 0. So 3 minus 0 divided by our denominator. So we have to look, what is the limit of 1? Because n isn't in a variable in the 1. We can see that it's just 1. It's equal to 1. And then we can subtract the limit as 2 over n. And this is the exact same. This is basically will get us the exact same answer as this, because both the denominators will be approaching infinity, which means it will be equal to 0. And then this final case with 1 over n over 3 is similar to the others, and it will just be plus 0. We can then simplify further, and we get 3 divided by 1, and we find this is equal to 3. Thus, our answer is D, 3.